Can you hear me? Yes, that's come up. Okay. Firstly, thanks to the organisers for letting me talk to you today. I'm going to give you a brief overview of Daiquiri. It's a UI-based UI framework for data acquisition with beamline control. So I'll start at the end. We are a small group that work dedicated on UI delivery at ESRF. Myself and Valentine are working full-time on this, and we have Marcus as well. We also have help from the data analysis unit. They're providing us with UI components, plotting libraries, stuff like that. And then I work within the beamline controls unit, and we're a big group of 20+ people. Lots of people have been involved in this development. We also stole loads of ideas from GDA and from Execute as well. So what is Daiquiri? Let's start with what it isn't. It's a framework for acquisition of beamline control, but it is not a scan engine. So if you want to use Daiquiri, you need to bring your own scan engine. And we interact with that through interfaces. It is not a control system either. We again provide interfaces to interact with other control systems. The project's split up into 3 core projects. So we have Daiquiri, which is a Python server. That exposes a REST API and SocketIO server. Then we have Daiquiri UI, which is the front-end client. That's written in JavaScript, in React, like a lot of the rest of the ESRF. And then we have Daiquiri Local, which is the local implementation of how you glue Daiquiri to your control system or to your scan engine. That's a cookie cutter project, so it's like a template. You can spin those up on each streamline. And in there we have wrappers to the control system, and we have config files and layouts and stuff in there. The architecture is nothing particularly unusual for a web application, if this works. Not quite. So server exposes a REST API, the client makes requests against this, and it gets responses back from the REST API. The problem with that is that if the server's doing something and you want to update the client, you can't send events back to the client. So to do that, we use WebSocket, and then say you start motor moving on the server, it will send updates to the client so you can see what's going on. In there at the top, there is an authentication handler. At the moment, we can talk to LDAP, but that's extensible. You can drop your own handler in there. We talk to the database, so we have MariaDB in there, and that gets information from the user office. Then at the bottom, we have a hardware layer, which is a small wrapper around whatever control system you use. So at the moment, we have adapters to Tango and Bliss, but you could put Epics in there if you wanted. We have runtime loadable components on the left. So you can pick what components you want to load depending on what your beamline is doing. And then the server loads that local project as well. So in there, it has a load of local Python, has configuration and layouts. And then that's how we interact with Bliss, which is the control system at ESRF, which Mattis will talk to you about next. So why would you want to work like this? So UI is completely decoupled from what's going on. It doesn't care what happens when you click a button. It just, makes call something else. That means we're not tied to what's happening below. Because we expose a REST API, you can consume that with other things as well. So you can consume it with the command line as well as a web URL. The way that we have that set up also means that that interface is really well documented. We do that automatically. And then once you have a web application, you're relatively platform independent. All you need is a modern browser to make use of this interface. In terms of stability, if the client crashes, you don't care. You just restart your browser and reconnect. And if the server crashes, again, most things exist in this database, so again, you don't really care if the server crashes. And really, the main benefit of this is remote access. A dedicated web UI will probably be more responsive than a remote desktop client would be, such as NX or Guacamole. So this is the first application we delivered Friday 21 at the beginning of the project. So this is quite like an MX experiment where we've got an online camera. So that's a view of the sample. On that, that's a live video view that you can move around, and you can mark points and regions on that, and you can execute scans against those points and regions. So at the top, we have all the things we've marked, and we can data collections against it, and then we can feed back, and we can generate maps from that X-ray data, and you can use that to inform the next part of your data acquisition. So it's hard to see up here, but that map has got a high resolution map within it because they started with that low resolution map. They marked a new region, they did another data collection. So you can use it to go around and use bits. We have a series of standard panels at the top and off canvas as well. So we have like state synchronous stuff, so you know whether you can actually collect data right now or not. At the bottom, we have sort of standard motor monitoring. So you can see the status of motors, you can see the state of the camera, You can see it moving backlight, things like that. Layout rendering is dynamic. So this is one interface, but we can quickly switch to another one. So now we've got a dedicated interface to tomography. This is the output from the tomography detector. You can align the sample, you can align the rotation axis, and then you can collect your data. And then we can switch again to something that looks more like an EDM interface for epics, where you've got a synoptic overview of the beamline, you can see the state of components, you can see some motors, you can interact with some components on the beamline as well, like the front end, and you can interact with beam viewers. Then we can switch again, now we can interact with the scan data. So this is mapped to Bliss's Redux database, so now we have a list of scans in the top left, and then you can see the 0D, 1D, 2D data if there was an image available. So the Python server, like I said, exposes REST API with SocketIO. We are geovented at the moment because we use Bliss. We have input and output marshalling, and when I say that, I mean that we model the inputs and the outputs from the REST API. That's important in a web application because you need to validate data you're getting from the user. By doing that, we also can generate the documentation automatically. Once you model those inputs and outputs, you can feed that into API spec and it will automatically generate the documentation for that interface. Then we can load the components as you want for what beamline you're running. So you might have a scan component, you might have that 2D view, you can pick. And yeah, so in CI, we generate automatically the full documentation of the REST API. So you can see what all the REST responses endpoints are, you can see what the requests are, what the responses are. So with the server, we implement a load of high-level concepts, which you'd expect from a data acquisition client. Because it's a web app, you have to log in. It's just the way it is. Because you log in, we know who you are, and we know whether you can do what you can do. When you log in, you also pick a session of beam time that's allocated on the beamline, because this is the only way we know whether you should be accessing the application or not. If we don't do that, then maybe last week's user could log in and start doing things, which we don't want to happen. And because we know what session it is, then we can set up where the data is saved to. The downside of it being a web app is that multiple people can log in. You don't want 3 people moving the same motor at the same time, so we have a battery control system like in GD and MXQ. So only one person can move the beamline at once. And then we have some rough support for session mirroring too. So because you're in a web client too, you'd like to be able to see sometimes for debugging what's happening on the client. So support for that. And then we have a queue. That means you can set multiple things going, you can leave them overnight. And we store some metadata as well. So we have user reference information about what sessions are active. And we store some information about the scans too, because the data in Bliss is only transient. So with those high-level concepts, we're trying to deliver 3 types of applications to users and staff. So the first one we have like totally integrated acquisition UIs, a bit like MX acquisition, MXQ. The idea is that the beamline does probably the same thing over and over again. And that means that we can do a really dedicated interface and the users can come along and they can interact with that easily and they should be able to get going quite quickly. Not all beamlines work like that. Some of them change their setup every week and you really can't deliver those sort of applications to those beamlines. In that case, we try to provide sort of a simplified parameterization. And by that, I mean, we'll give you a little form you can fill in with some beamline parameters, and we just save that to disk. And then the staff can do whatever they want with that, run a command line, scan, or something else. And then in the simplest case, we want to provide monitoring for beamlines where they just want to see the state of some motors or the state of some components on the beamline. And the idea is that VCU staff can deploy 2 and 3 without the UI group, is what we're aiming for. The client side is in JavaScript, like I said. It has this dynamic layout renderer, so you can change those at runtime. Then it has some common panels. This is a fairly standard stack for UI development at ESRF. We're currently migrating the project to TypeScript. That's quite cool because from the marshalling we do on the server side, we can generate TypeScript interfaces automatically, so you don't have to write those by hand. And we're currently migrating from Plotly to use a load of internally developed plotting libraries. All of the UI components are mocked up in Style Digest, which is built in the CI as well. So that means beamline staff, VCU staff can see what all the UI components are, how they can be configured, and what they can use on their beamlines. Layout is written in YAML, and it's just a tree of like containers, rows, columns. So you can build like standard grids quite easily. And this maps to Bootstrap's grid system, if you know about that. And then into those rows and columns, you just drop like UI components into that. We have some basic support for templating and partials so that we can have the same like 2D view that I showed you at the beginning, and that can be reused on many beamlines, and then you can drop your own motors and stats with you. Schemas and forms. So again, because we're using this marshalling, say a staff member wants to design a new scan, you write a schema for what parameters you want to accept, how they should be validated, and you can do all that in Python. The UI will then, because we convert these schemas into JSON schema, which can be used on the front end, we can then generate forms like this dynamically from Python. So that means BCU staff can write quite nice interfaces without having to know anything about JavaScript. That's quite good. In terms of global infrastructure, so Daiquiri talks to ISIB, that's the database we're using underneath. Because we're doing that, we can then monitor the beamlines passively using ISIB and Sync. We can also interact with automatic processing libraries as well. So things like Zocolo, which is a BAM, EWOX, which is being developed at ESRF. And so Daiquiri can say, I've done a data collection, it sends a message to the automatic processing system. Processing system goes away and does its thing. It sends messages back to tell Daiquiri what's going on. It can then write its results to a database. Daiquiri can read those again. And if you don't know what all of these projects are, various people are going to present these later in the conference as well. So Miles will present PyS5B, I think Rich is presenting Zocolo, and Vat will give an overview of EWOX as well. Daiquiri injects a load of useful metadata into its log files as well, to its log messages, sorry. And that means that you can feed all the log messages into Greylog, and then you can centrally monitor all of your beamlines. And when something goes wrong, this is great because you can go through the log messages here, they all come to one single place, and you can find out where things are going wrong. And we can monitor things like the startup time, so we know if something's wrong on a particular beamline, we know whether the data's coming from the user office, so we know that people can log in. That's useful too. The whole project is containerized. If you use Docker, you know about Docker. So we have Daiquiri Docker, which involves server, UI, it includes Bliss, and a series of dummy devices. And then we have a Mox database, which you can spin up as well. If you spin both those containers up, then you can start Daiquiri up and you can start playing around with it. And that's my primary development environment. I drop my own code base into there, and I can develop on the fly with that Docker. And they're in the public domain if you want to go and try it. So the current status, we're in production on quite a few beamlines now. It's on ID21, and that was the first interface I showed you. BM29 does BioSAXS, and it has its own custom front end. We're in production on ID13, and then some other things on a few other beamlines. And we're currently deploying to another 4 at the moment as well. I've put links to all the different projects. There's quite a lot of code which you can go away and look at. And that's about all I have to say to you. Thank you very much. Sorry.
Thank you very much. We've got time for a few questions. Any taker?
How scalable is the infrastructure that you set up here with Daiquiri?
There's lights off, but I can hear you. It's okay, just the remote people won't be able to.
Oh, sorry. Well, perhaps you could just repeat the question.
Yeah, what was the question about how scalable it is in terms of?
Just in terms of how you can use it. So I know you mentioned that you do everything with Docker, but when it's actually deployed with beamlines, is that on a sort of infrastructure to support containerization?
We don't deploy containerization at all, actually. Each installation is unique for each beamline. So every beamline has its own install of the server and of the client. And then if you want to access it remotely, we have a reverse proxy. So everything gets fed through reverse proxy. So you can access it externally through that. So yeah, most of the load goes through reverse proxy. We don't actually do that yet, but that's the intention.
You mentioned with authentication, beamline staff always has access. Do they all have the same access level, or do you have different privileges there as well?
Staff have access to their beamline, so you can give. It's up to you who you assign this to. Users can only access their sessions. But beamline staff can access all sessions on that beamline. And we have a grace period as well, because sometimes staff want to access a proposal that's about to start because their users have arrived the day before and they want to start setting up samples and things like that. So we have grace either side of when the session actually starts.
Right, thanks.
So you have a facility that's been operating now for quite some time. You have challenges in upgrading instrument staff to use the new tools.
Depends who you talk to and how open they are. Yeah, right. So moving to web technology is, some people don't like it because they're used to their Qt applications, they do not want to use web applications. But if you, again, it's as usual, when you're writing good software, you have to provide more than what was there before. If you provide less than what they currently had, or the same, they don't care because it's not doing anything new for them. But if at the same time we're deploying this, we can provide new features and things that are useful to them, it's easier to push them towards using new technology. I don't think we've got much pushback for the main user interfaces we've deployed. IO21, they drove the whole development pretty much. They knew what we wanted, and we converted that from requirements into deliverables.
Let's follow up on that.
Go.
What feature has been the most attractive for those users?
So for IO21, the things I couldn't do before is in this interface. So historically, this interface, it had no data persistence. So when you close the UI, everything went away. Also, this interface, you can see the camera here. This is the on-client camera, but actually this view is not fixed. You can unclamp this view and you can zoom out, so you can see wider than current field of view. And then you can raster the whole sample. So you can, you've got samples bigger than the field of view, you collect images all across it, and then you can actually disable the video camera. And some beamlines, they don't have their camera online, they take it off again afterwards. And now you can start designing these things essentially offline, as long as you know where their focus is and things like that.
So my question is regarding this HashPyD. So this is quite tight for all beamlines are using HashPyD for this application.
We only have this on those 5 beamlines at the moment, and it depends what type of application they're using as to how heavily tied it is to HashPyD. This one is storing like regions and points and samples. So the dedicated one ties quite heavily to HashPyD. The simplified parameterization where they just have a form, it doesn't care about HashPyD because you're just saving stuff to disk. We're not like persisting stuff into the database. So that depends how the beamline works and what you can actually do.
So and all the data processing workflows and everything puts information back in HashPyD and all these different.
It can do, it doesn't at the moment.
Okay.
We haven't got a lot of online processing. This processing is just sort of really simple integration of the spectrum. We're not like doing like integration things like that yet.
So this will be the last question, so we have some time.
Thank you. So you said the ROIs are stored in HashPyD, you're looking at using units for other processing. Where in larger process data, where is that stored? How do you get information about that back into the file?
So you just put a link to the file and then you can access the file. We don't actually the ROIs are different because we're basically storing images there, but for anything else, we just store an HDF5 file. If you've done like tomography reconstruction, we're not going to pull out anywhere in datasets.
So do you use Nexus or anything to determine what's in the HDF5 file to produce?
That my DAU colleagues would know more about. Someone like that would know what actually goes in the HDF5 file.
Thanks.
Thank you very much.
Thanks a lot.
And we switch to the next speaker, Matthias. We'll talk about